In this presentation, we're going to talk about looping and how it can be used to solve a lot of common problems that we have in computing. So as an overview, we'll talk about iteration. We'll talk about the three kinds of loops that are in Java, specifically the for loop, the while loop, and the do while loop. And then we'll also talk about infinite loops, what they are and how to avoid them. So the term that computer scientists use for looping is called iteration. And if there's one thing that computers do really well, it's to repeat commands over and over again. So as I stated before, we have three different kinds of loops in Java that are available to us. It's the for loop, the while loop, and the do while loop. Now, no matter which loop you use, certain criteria have to be satisfied. You typically have some kind of starting position or starting state that you need to begin in, such as starting a counter or beginning in some particular kind of state. You have to have a test to continue, and then on the inside of the loop, you have to make some kind of progress towards finishing that loop, some kind of termination. And so this could be something like incrementing or decrementing a counter, or it could be some other kind of state change. So imagine that we have a bad child and we want this child to write sentences on the board. For example, I will not pour Clorox in the fish tank. We could do this a couple different ways, such as a certain number of times. We might have 100 sentences that we have to write, maybe until the teacher is happy, or as many as you can during a fixed period of time. So let's look at the for loop to begin with. The for loop is good when you know exactly how many times you need to execute something, and it has this format that you see right here. Now the for loop has a pair of parentheses, and on the inside of those parentheses you have three things separated by two semicolons. On the far left, you have some kind of an initialization, and this is usually where a counter is given some kind of starting value. In the middle, we have a test to continue, and if this thing is true, then we're going to continue everything on the inside of the loop, and you can see that it's highlighted in green. And then the third thing that we have says an increment, but it's really some kind of progress towards terminating this loop. Okay, so let's see an example of this. Let's say that we had to write 1,000 sentences and the student could write some code that accomplishes that. So here you can see that we've declared a counter. The first line right there is int counter, and then we have the standard structure here for our for loop. So let's trace through this and see how it behaves. Okay? If the teacher wanted them numbered, which is typically the case, then we could also include the counter, and you can see that's highlighted here in red, and we could put the counter right before the sentence that we have to write. So let's see why this works. Well, the counter starts out at 1, and so long as the counter is less than or equal to 1,000, it is in this case, then we're going to go inside the loop, and we're going to print out, in this case, 1, I will not pour Clorox in the fish tank. Then we go back to the top of the loop, and then we increment the counter. So you can see that we've executed everything on the inside. We go back to the top, we increment the counter to 2, and then this continues. We test to see whether or not the counter is less than or equal to 1,000, and it is, it's true. So we go inside the loop, and we print out 2, I will not pour Clorox in the fish tank. Go back to the top of the loop, counter plus plus, so now the counter is equal to 3. 3 is less than or equal to 1,000. So we go into the loop again and output 3, I will not pour Clorox in the fish tank. And you can see this is going to occur any number of times. So the question is, when is it going to end? Well, it gets a little bit more interesting as we get closer to that 1,000 boundary. So let's increment our counter up to 999 and see what's going to happen here. So is 999 less than or equal to 1,000? That's true. So we're going to output 999, I will not pour Clorox in the fish tank. And we go back up, increment our counter now to 1,000. So what do you suppose is going to happen? Well, if we do this test to continue, you can see that the value 1,000 is less than or equal to 1,000. So this is going to be true for the last time. So here we're going to print out 1,000, I will not pour Clorox in the fish tank, but we still go back to the top of the loop here. So we still increment this counter by 1, and the counter actually makes it to 1,001. Now watch why this is important. Because when we do our test to continue, you can see that 1,001 is not less than or equal to 1,000. So we're going to kick out of this loop, and then you can see this green comment here. It says that we're going to jump down there, and then we're going to continue processing past that point. So our final output is going to be 1, I will not pour Clorox in the fish tank, and this is going to repeat any number of times, and then finally we have 1,000, I will not pour Clorox in the fish tank. So the next thing that we're going to look at is the while loop. And this is good when you don't know exactly how many times that you're going to repeat something. For example, if the teacher says, I want you to write until I'm happy, then that's a slightly different thing that we had seen before, where we knew we needed to start at 1 and then we wanted to finish at 1,000. The structure of a while loop is different than a for loop, though. You can see that on the inside of the while loop, this pair of parentheses that we have, that we only have a Boolean value. And then we also have the stuff that we need to repeat over and over again on the inside of the curly braces, just like we did with the for loop. So here's an example, and it's a little bit strange, but you could see we might have a Boolean called teacher happy, and we set its initial state to be false because the teacher is angry at us. Right below that, we declare another variable called line number, and that's going to start out as the value 1. And then so long as the teacher is not happy, we're going to system.out.println the line number, which in this case is going to start out at 1. I will not pour Clorox in the fish tank. And then we make some kind of progress here on the inside of this while loop, line number plus plus. And then we need to somehow check to see if the teacher is happy, and don't worry necessarily about what's going on here, but just realize that the teacher happy state could change to be true, at which point this while loop on the inside right here is going to turn out to be false, because not true is going to be false, and then we would continue past that point. Now let's see a different example of using the while loop, and we'll just kind of rewrite what we had previously done as a while loop. So we'll start by declaring a variable here called counter. Now previously in the for loop this was on the inside of the for loop, but for a while loop we're going to take this outside just above the while loop. So we start our counter out at 1, and so long as the counter is less than 1,000, then what are we going to do? We print out 1, I will not pour Clorox in the fish tank. So what's going to happen? We go back to the top of the loop and then we do our test to continue, and you can see that our counter still has the value of 1, and 1 is less than 1,000. So I'll print out 1, I will not pour Clorox in the fish tank again. We go back to the top of the loop and we do our test to continue, and you can see that 1 is still less than 1,000. So you can see that we're going to be printing out 1, I will not pour Clorox in the fish tank, basically an infinite number of times. So that's really not a good thing. So this is our discussion about infinite loops, and this is going to occur when you have a loop that isn't making any kind of progress. So loops that repeat forever are called infinite loops, and they apparently lock up your machine. That's not necessarily true. You still have a program that's running, but it's just going to print out the same thing over and over again in this case. So how are we going to solve this problem? Well, let's make progress on the inside of the loop. And this is a very common mistake for novice programmers to make. They forget to put this counter plus plus on the inside. So let's run through this again just real quick, and you can see our counter starts out at 1. 1 is less than 1,000, so we're going to print out 1. I will not pour Clorox in the fish tank, and then we make progress by incrementing the counter by 1. Now the counter is 2, so you can see that 2 is less than 1,000, so we're going to print out 2. I will not pour Clorox in the fish tank, and so on. Okay, so how's it going to end? Well, let's bump our counter up here to 999. And you can see that 999 is less than 1,000, so we'll print out 999, I will not pour Clorox in the fish tank. Now this is where it gets a little bit more interesting. I increment the counter here to 1,000, and I go back up to the top, and now I do a test to continue, but it's false. So we never really made it to print out 1,000, I will not pour Clorox in the fish tank. So how might we solve this? Well, there's a couple different ways. We might change the 1,000 to 1,001, or we might just add in a less than or equal sign, at which point 1,000 is less than or equal to 1,000, so we could then print out 1,000, I will not pour Clorox in the fish tank. All right, the final loop that we need to look at is the do while loop, and this is very similar to a while loop, but it's different in a way because the test to continue is at the bottom. And so the result of this is that this loop has to execute at least one time. So let's see an example of how you might use one of these do while loops. You can see at the top we still have a variable called counter that's going to start out at the value 0. We have the do statement, and then once we get inside the loop, we're immediately going to increment our counter by 1. In this case, counter is now going to equal 1. So we can system.out.println just the counter in this case. And so the output is going to be 1. Now if you notice, our test to continue here is at the bottom. So we say so long as the counter is less than 3, we're going to go back to the top of the loop. What do we do inside the loop? Well, we have counter plus plus, so counter is now 2. So we system.out.println counter, which is going to print a 2 to the screen. We do our test to continue, and you can see that it is still true, right? So 2 is less than 3, so we go back to the top of the loop. We have counter plus plus, so now counter is 3. And terminating this loop, you have to be really careful on how it's going to finish out. So what's going to happen here is we system.out.println counter, and counter has the value 3, so a 3 pops out on the screen. And then we have our test to continue, and this is now false because 3 is not less than 3. So in summary, for loops are good when you know exactly how many times you want to repeat something. For example, 10 times or 100 times or 1,000 times. While and do while loops are good for when you don't know how many times that something needs to repeat. But no matter what, there's always criteria that you have to satisfy. So all loops have to terminate or they become infinite loops. And then all loops have to have some kind of test to continue or they become infinite loops. So hopefully you understand a little bit more about the 3 different kinds of loops that we have in Java.